Let's spend a few minutes looking at what we call an energy profile diagram for a reaction. Okay. When we look at thermochemistry and heats of reaction, we look at a reaction and define it as either exothermic or endothermic. Okay. This profile diagram here is of a reaction that is exothermic. Okay, this is an exothermic one. Remember that exothermic reactions mean that heat energy is being released from the system. And how I remember this is exothermic sounds like exiting. So energy, heat is exiting the system and being released. So what an energy profile diagram does is it has a y-axis that's just listed as the energy, and sometimes you'll see numerical values over here labeled on the axis. And then you have what they call a reaction pathway or reaction progress. Sometimes they'll just have the word reaction progress written down here and showing you that. Okay, what it does is it gives you the initial energy state or energy value of your reactants. So in this case, the hydrogen gas and the oxygen gas gives you their energy values and then shows you where the energy of the products, in this case the water, the energy of the products exists so that you can make a comparison. When we look at this profile diagram, we notice that the energy of the reactants is greater than the energy of the products. That is customary for an exothermic reaction. An exothermic reaction, the reactants will have the greater energy value. Okay, this because part of the energy that they originally possess, when you break these bonds and these new bonds are formed, that energy that is exiting the system is leaving the system, so that means that our products will have a lower energy value. There won't be as much there as originally because a part of the energy, and we can tell which part is how much, is from this value here to this value right here. This is our enthalpy change. Okay, this is our enthalpy change, okay, which is often referenced as our heat of reaction. Okay, we can see how much energy is exiting the system. Okay, so this is an exothermic reaction. You have the energy of the reactants greater than the energy of the products. And an endothermic reaction, one where energy is being absorbed. So if this was an endothermic reaction, we would be absorbing energy as the reaction progresses rather than losing. Our energy of the products would be above the original spot where the reactants were. So if this was an endothermic reaction, our curve would happen. We would have some sort of slight drop, but the products would end up maybe right here, somewhere above the original or initial state of the reactants, because for the products to have a greater energy than the reactants has to be, there if we're going to absorb energy. Okay. Now, after looking at this energy profile diagram, you may be wondering, what is this label right here, the activation energy? Activation energy is the minimum amount of energy that a reaction collision needs in order for those molecules, those particles, to react. Okay, so activation energy is the minimum energy needed for a collision to be successful. Okay, now collision, what I'm talking about is when you react substances, when these hydrogens and these oxygens react, they have to collide with one another. They have to physically run into each other. When they run into each other, they have to hit with enough energy to actually separate. Okay, we've got to bust these apart. You see, we want one oxygen with two hydrogens. So we have to split these and split these. Well, if they don't collide with enough energy to do so, these molecules won't split and then be able to form these new water molecules. That's what an activation energy is. It's always the height of this hill. Sometimes you'll see them label it with an E and a subscript A for activation. So if you see that, it's just the height of the hill from the original reactant's energy value to the top of the hill. Okay, that's the activation energy. Okay, the enthalpy change, the heat of reaction, is the energy difference of the products and the reactants. Okay, that's what the enthalpy of a reaction is the energy of the products minus the energy of the reactants. Okay, that's what the enthalpy is. The activation energy is just simply the height of this hill. Now, thinking back to your notes, there was a second factor that influences whether or not a collision will be successful and produce a reaction. First factor is this activation energy threshold must be met. The second factor is the molecules must collide with the proper orientation. What that means is the molecules that are reacting, they have to hit each other at the right position. Like, for example, if these two hydrogens run into each other, it will not produce a water molecule because there's no oxygen involved. If these hydrogen here react with this oxygen by colliding, they have to hit correctly. They have to hit the right position so that the bonds inside of each one of these will snap, will break, and then immediately those separated atoms will be able to form the new bonds correctly. Okay? If you don't hit with the correct orientation, the correct position, it won't matter if the activation energy is met or not, because you won't be hitting in the correct spot so that the new bonds can form immediately after the original bonds are broken. Okay, you have to hit at the right position. Now, another aspect to look at on an energy profile diagram is what will a catalyst do to a reaction. A catalyst is a substance that speeds up the reaction without itself being part of the reaction. See, this here is our hydrogen gas, here is our oxygen gas. They are the reactants. The products are the water molecules. A catalyst makes this reaction happen faster, quicker. But nowhere in the products do you see this catalyst in that chemical formula. Okay? A catalyst makes the reaction go faster, go quicker. How it does that is it lowers the activation energy. You don't have to have that great amount of energy in your collision. It does not. Now, the catalyst is not about the orientation of the molecules. You still have to hit the correct position in order to form those new bonds correctly. What it does is it drops that energy value that's needed. You don't have to hit as hard. Okay, you don't have to hit as hard. Another thing I want you to remember about the presence of a catalyst does not change whether a reaction is exothermic or endothermic. Okay, it does not change that. If you notice, this is an exothermic reaction. The enthalpy of a reaction is the energy of the products minus the energy of the reactants. Okay? That is what that is. That is the difference between here and here. Okay? That value does not change with the presence of a catalyst or the absence of a catalyst. Notice the amount of energy between your starting point of reactants and your finishing point of products is the same amount regardless if there's a catalyst or not. Okay? The enthalpy reaction does not change. What a catalyst does is it lowers the activation energy. Okay? You still start at the original reactant's energy, you finish at the product's energy, but how much the collision, the minimum amount of energy needed for that collision to be successful, is what is changed by the presence of a catalyst. Okay, so in review, exothermic reaction, what we see happening is energy is released from the system. Your enthalpy of reaction is going to have a negative value because you're losing energy to the surroundings. Okay, in endothermic reaction, energy is absorbed as the reaction progresses, so the final products have a higher energy value than your reactants, and we would see an enthalpy value of a positive number because of that absorption of energy rather than the release of energy. Okay, so on an exothermic reaction, your profile diagram, your products are lower than your reactants. In an endothermic profile, the products are higher than the reactants because of that absorption. Okay, because of that absorption. And a catalyst, finally a catalyst, just gets you from the start reactants to the products quicker, sooner, by lowering the activation energy. It does not change the value of the enthalpy of reaction. It does not change your delta H value.